hit record.
Okay, I'll mute mine so it'd be a nice clean recording.
All right, and then Mason, what do we just need to start with? Just who was assigned like to teach a thing today, or?
I mean, we can. It was just you and me, I'm pretty sure.
Right. Okay.
I didn't know if you wanted to go first or me or.
I can go first. It doesn't mean that it'll be good, but we can go.
Okay, yeah.
All right, so I'll share my screen here. Okay. Shrink these out of the way. All right, so can you guys see that, sort of?
Mm-hmm.
All right, so I'm doing Java collections today. And I've put up just a collection framework. So the Java collection framework provides some predefined classes and interfaces to handle the group of objects. There are two main ways that the group objects in Java are kind of collected together. There's our collections, which will be our lists, our queues, our sets, and then we have maps. And that's just kind of showing here how they're broken down. And of course, we have our trees that fall under our sorted maps and our sorted set. And then on, if we look at the collections, there are certain collections where they will allow duplicate elements and others that do not. Some are ordered and others are unordered. And so we're going to talk about just a few of the main ones that we might see. So under list, these can contain duplicates and the elements are ordered. And a common one that we use quite a bit is an array list, which is a collection that is assessed like an array. It can be sorted. It supports dynamic arrays, so it can grow as needed. In a set, it doesn't allow duplicates. And in a tree set, this is going to use a tree for storage. The elements are sorted by keys. The objects are stored in a sorted and ascending order. Duplicate values aren't allowed. Tree sets serve as an excellent choice for storing large amounts of sorted information, which are supposed to be assessed quickly, and it just provides faster access and retrieval time. In a queue, typically these order elements are first in, first out, and it allows for duplicates. And a queue, because it is an interface, it can't, we can't start it, but we can use a linked list, which is an unsorted collection where objects can be added in any number of times. And this class usually also sorts itself in kind of a first in, first out behavior. And we can also use a priority queue, which will assign to the queue. And then we have maps, and maps contain a key value pair, and it doesn't allow for duplicates. And then there's two most commonly used maps, which are hash map and tree map. And one of the biggest differences between them is a hash map is an unsorted set of key value pairs, and in a tree map, it's a set of sorted key value pairs. And then I thought I would just show quick, if I can get out of here, because that was the end of my slides. I figured I'd just show a little bit of code that I used in mine. And so in the example that I used, of course, I just called the method of where I was showing the examples. The great thing about in collections is that the root collection interface, we can use a lot of the same methods. So we'll use the add method, remove method, contains method, is empty method. We could use add all or any of those types of things among them. And so because collections can grow dynamically, we just do that by adding and removing what we want. And so here in the array list, I'm just making a list. I'm adding some names. We can print stuff out. We can find out the size. We can grab it by the element or the index number and pull things out. In a tree set example, again, we're adding and making a list, and I'm calling them by the actual collection name. And so I'm making a list, and the type of list that I'm using is an array list. And that's the way I'm calling it. So down here, I'm calling that I'm going to use a collection set, and I'm going to use a tree set or a sorted set to do that. And again, we can add and remove. Now, because I'm calling it as a set here, I can't use just a straight to pull out the last element of the list without using a typecasting first. And so here I'm saying I'm going to typecast it to a tree set string of what I've called to be able to pull out the last assorted ascending item that's or element that's in my tree set, in my set. And then you can also not just use strings. I did one with numbers and kind of ran it. And then in my hash map example, we put the items into the map, and there's, you have to have a value and a key. And it doesn't take duplicates, and so we can see that it removes the duplicate, but it'll keep whatever was entered last. So if I have a Randy 50 and a Randy 18, it'll be Randy with 18 that we'll see as it appears. And then here's our sample of my tree map example. And then I have a queue down here at the end. And the great thing about the queue is that there are several methods that you can use that do a very similar thing. And so you can ask for what is the next item in the queue by the element, but then you can also pull them. And the difference is if it's at the end of the list, it will just return that it's empty, whereas in the element it won't. And then you can also do peek, which will kind of tell you what the next one is. And so that's what I learned about Java and collections. So that's what I have.
So I had a question actually.
Okay.
Is there an advantage to using the typecasting instead of just straight up making it a tree at the beginning?
Well, when you're using a collection, this is the proper way to call them, where you're listing them under the interface that you want to use, instead of just calling it as a tree set. I don't know what the advantage is, because they do the same, but somehow there is more, I think there's other applications or things that fall under in that umbrella and the framework of a set versus just running a tree set. I don't know. I just know that everything I read said this is the proper and more better way of programming to show that we're using them. But I just realized as I went to use last and also I think it was first, I could not use them. They don't come because they are listed as lists and maps, which is the generic framework of them. But I don't know.
Cool.
So if someone else knows, that would be great. So I'll stop sharing. But that's what I have.
Cool. I guess it's my turn then. Let's see here. Can you guys see this?
Mm-hmm.
Yeah.
Cool. All right, so threads, executables, and runnables. We're gonna start off with executables. I couldn't find a lot of information on it because it's kind of hard to find sometimes. But executables are mainly just meant for running things in Java. And you can run runnables or callables, and it goes along with the whole thread situation. And I have some links here that have examples in them. So in this one, we have the executor service, and it just makes a new single thread, and it submits it, and it makes a pool of one thread. And you can put in try catch finally block, and it does shutdowns and all sorts of stuff. And you can do callables like this. It's considered an executor. Let's see here. With this link, it also does the same thing with a callable executor service. So yeah, this one is a little bit complicated. It's kind of weird. I don't see a whole reason why you would use this versus threads and runnables, since you could just straight up run them. But we'll move on to those. So with threads, you can have a single thread or you can have multi-threaded applications. And so the best example I've thought of or heard of is if you think of it like a grocery store where the threads are cashiers, the more cashiers you have, the faster the lines are going to move, and then customers can go through those lines, right?
Right.
And so single thread applications are great when there's only going to be like one customer going through at a time, or if you want to haul all the customers through this single line to make sure that all the data is there and everything's running fine. A good example of that would be if you have a database and it's going to lock this file, you don't want multiple things trying to lock it. You only want a single thread kind of thing. If that's not a concern, you can have multiple threads and everything just running through. But if each customer is only going to do like something really simple, like say they only have one item in their shopping cart kind of thing, then having 50 cashiers for like 100 customers isn't gonna do anything but make more overhead. And so it'll run slower than if you only had like a single thread. And so the main problem, which I think Melissa came up with in the discussion board last week, was that the main problem with implementing a thread is that you just can't extend another class. And I replied to her last week about that. But basically, if you're extending the thread class, you can't extend another class, and so it makes it harder to do anything but run the threads inside that class, which is where runnables will come in. And so here's an example of like multi-threading in Java. And this one you can actually run inside here, and it will just straight up run the code. It also has a runnable example down here, but we have better runnable examples. So yeah, there's that. And so runnables can create and execute threads in an implementable class like threads, or they can just be used as an anonymous class. And anonymous classes are a little bit easier to deal with in my experience. So let's see. And the Stack Overflow, it has an example of anonymous type actually, where you can just call it from anywhere in a code. So you can make a thread, make a new thread runnable, and make a short little thing here and start it in just about any class, or you can do an implementable like a thread does and start it just like a thread does, except it's a little bit easier overall. And here's a good one. And let's see here. I picked this for a reason. Oh, this explains the inheritance that Runnable does and the modularity and why it's easier to use a little bit. So it's easier to use because it only has the public run, and whereas Thread has a bunch of different things that you could do with it. So yeah, that's what I got.
So
Any questions?
I don't know if I have a question, but I was thinking when you were talking about executables or executors, what I had read on there is that when you do a runnable, you hit run, but you still need to make a new instance of a thread to actually get the runnable to start. That's what we're showing in the thing. And an executable doesn't need that. We don't ever really call the thread. We never write a thread in the code. The executor service will actually already do that. It'll just read to the runnable, and it runs with a runnable. And the difference between a runnable and a callable is a runnable never returns a value, but a callable can. And so you could take it and have it go run a task, and it can return a value for you. That's the only difference between a runnable and a callable.
Cool.
At least that's what I read.
Yeah, that makes sense.
And so a lot of times we use a runnable with an executor service or with the executor class because it already takes out and does the calling of the thread and the start that you need, because a runnable uses a thread. And so we can, and the reason we do that is that's why we call it that it's extending the thread. We either say we're extending the thread class, or we have to write a thread in there. That's
Cool.
what I saw when I was working on it last week.
Yeah, I haven't written any code for it yet. Which is why I was going off the examples.
Right. Yeah, because I wrote, so the first, what I was actually trying to ask, well, and I still never really got a really good answer. What I was trying to figure out is they show in there that the easiest way to implement a thread is by extending, just extending the thread class or whatever. But then you can't extend anything else. And what I was asking is, when would you, in a program, would you want to just extend the thread class? When would you ever use that method? That's what I was asking. I understand it's not great thing, but I was just wondering when in the thing. So I guess if someone was just calling in and it was only to get into something, you could always just say, hey, I'm just going to extend the thread to run the check as they come in. I don't know. I was just wondering when you would ever just use extending the class. Yeah, like when that would really be, when they were saying that's a really easy way to do it, but it's poor programming or whatever.
I think it might be when you're making a pool of threads,
Okay.
because this is making, a bunch of threads that are just going to sit out there and do stuff, but I'm not entirely sure.
Right. Because that's what I was just thinking in my mind. I was thinking most of the time we're talking that we want to take advantage of that processing and that data that's already been reserved, that's not being used in different places, and we're trying to take advantage of using these extra threads floating around and letting them run at different times. And so I was just wondering when you would ever just use a single thread being extended, knowing that's all you could do with it. Because that is what they teach first, and then say, oh, but it's not a really good idea. You should always run a runnable.
Yeah.
Has anybody else had a study on it or looked or no?
I haven't looked at anything like that. It's a pretty interesting thought, though. I've never considered that.
Because I really liked your analogy using the cashiers and the different things, because obviously we could go at different speed for each, as we're rolling items or whatever, but I was just trying to think, when would we ever use just an extension of the thread?
Yeah.
Because it's what they show us first, but they say really it's not very good programming and that you should implement a runnable.
Yeah, that is interesting.
And I just couldn't think of any reason why we would ever when you would ever just use it. I mean, obviously we do, because we use it and they still talk about it. I just didn't know when we would.
Yeah, if I find anything out about that, because I'll probably end up doing the code for this later this week.
Right. Scroll down to the next example. I wanted to look at the runnable real quick.
Yeah, the runnable does the exact same thing as the other one, except it implements runnable instead of thread, so they're
right.
pretty
So
much
we
the exact same code.
Right. So we implement runnable, and then it does the run, and then somewhere right here is where they have to introduce the new thread. See down here?
Mhm.
But if you look at an executable service one, you'll never see new thread written in it in the code. It'll implement a runnable, but then the executor calls the runnable. And so in it, it is already taking care of building that thread, starting the thread. You can do a thread count and a thread name, but it doesn't call a new thread instance.
It's
And
interesting.
that's somehow what that executor does, is that it automatically takes care of creating the thread that is in the thread that you would need when you're running without one.
Cool.
So that was the only advantage I saw. And then, like I said, I read that it can also take callables, and the only difference between them. And then again, I was trying to think what value I would want to return or need to return. But obviously, it'd be something I wrote in the code that helps with the runnable or whatever I'm running.
Yeah, like you could return something like a number or how
Right.
many seconds it took. So if you wanted to do like metrics or something.
Right. So
then-
somewhere, if I'm keeping
Yeah.
track of something, I could have it return, hey, when it does this process, return whatever. And that's
Mhm.
the only difference between a callable and a runnable, is a runnable does not return anything. It just runs the code. And then the other thing I learned is when you use an executor service is that you have to then shut it
Shut
down.
Yeah.
Shut down at the end.
Yeah.
And
Because
a
otherwise it'll
shutdown,
just keep going.
right. And it will just run through your cycle depending on how you wrote your statement of how you're doing your runnable, but it doesn't immediately shut it down. It waits till it runs its cycle, but then you have to shut it down.
Hmm.
And that was the other thing that I'd seen or learned with working on it last week.
Cool.
So is there anything else? I was trying to think what else we need to cover. Does anybody have any questions or things they've been working on?
No questions from me.
Yeah, thanks for the lesson. That was some good information.
Yeah, I'll probably just make this slide thing readable and put it on the group discussion board somewhere,
Okay.
or export it, one of the two. So you guys can look at the links if you want.
Right. And I can add a few links to mine. I hadn't thought about putting links. I mainly had just taken from the notes of things that I'd been working on and had learned myself as I was reading along. It looks like Giovanni was having trouble. He was sent a message over in Google Hangouts. And I was just
Yeah.
saying, we'll send a link and he'll hopefully be able to hear it.
Oh, wait. Me?
Gary.
Gary, sorry.
Okay.
Sorry. I was seeing a G. I was trying to think, G, which G? But then I realized there was two Gs, a purple and a gray or lavender color. I was trying to see which G went to who. Somebody was having trouble.
Yeah.
Hey guys.
What's up?
Hey, Ronald.
Hey, how are you?
Good.
I'm a little bit sick, so I can't talk a lot right now. Sorry about that.
No
Hey, I have
worries. Go ahead.
So this week we are looking. You guys already checked the Java collection, right?
Yeah.
Yes.
Okay, so I'm looking here the schedule, and today we're supposed to see the number 3 and number 4, or
No, 3 and 4 is next week.
Yeah.
okay, so that is the next week. Okay. Oh yeah, I saw here. So another question. So on the like in GitHub, or we need to write the codes like any code that we found on the web, or how we're supposed to do that?
So you can look, like I read and see the tutorials and the codes that are on line, but then you need to still make them. You could use it as a framework or a kind of a model, but then you need to write the code yourself.
Okay. Okay, yeah, because right now I'm looking like a lot of tutorial and try to have the idea how to make the code and make something with my, I don't know, with my ideas.
Right,
But I don't know if that is right. It's how it's supposed to be, right?
right.
Okay. Okay, I was a little bit confusing.
Right. Yeah, from what I can tell is that it's supposed to be our own code.
Yeah, you can grab examples
But-
from the internet, but
Right, but I definitely followed a framework. I saw kind of, 2 or 3 different runnable, running ones, and then I changed up what I was looking for, what I was using, and then wrote my own. But I followed really close to similar layouts of ones I had read and looked at in the tutorials.
Yeah, it should help anyway with the proving fluency or whatever they call it this semester, and because you have to show that you know how to write it anyway.
Right.
oh, so any more
Alright.
questions?
I think I'm good. Thanks for the presentation again. I really do feel like I learned a lot.
Yeah, both the presentations were very good.
Thanks, guys. You were great.
Well, same time next week.
Yeah.
I believe so.
Alrighty. Well, thanks again, guys. I'm sorry I didn't make it last week. Kind of got all mixed up trying to still get a hold of all the classes I've got.
Right. Who's teaching next week?
So it'll be me and Robert will teach.
Okay.
So Robert will probably go first since he has limited time.
Right. Okay.
So he'll
Okay.
do the first one and I'll do the next one.
Perfect. And then I will, when we're done, I'll get this ready and post it up to YouTube, and then I'll put the link on our discussion board. And that way you can go back and look and see the links and stuff there too.
Thanks, that'll be helpful.
All right. If that's it, then I'm going to go ahead and stop the recording and we'll call it good for this evening.
Okay, sounds good.
All right. Thank you guys so much.